So last time we were talking, right? So polynomial fx divides gx if there exists another polynomial same set rx, is that gx is fx times hx. So and every polynomial divides itself. This is what we discussed last time. So state x and x be non-zero polynomials. In x, we are basically considering real coefficients. So rational coefficients includes integer coefficients, right? So p and q are non-zero polynomials in Rx such that p of x divides qx and qx also divides px. So what can you say about such polynomials? So now you understand the meaning of px divides qx. So same idea you can think about integers. This is the idea. If m and n are integers and m divides n, also n divides m, then what you can say about these two integers? If these two integers divides each other, then what can you say about such integers? Yes. What can you say about such integers if integers divide each other?
They are equal.
Not necessarily equal. Do you understand? 2 divides minus 2, am I right? Is it true? 2 divides minus 2, correct?
Yes, sir.
Right. And it is also because why 2 divides minus 2? Because minus 2 is minus 1 times 2. There is another integer minus 1, but so certainly 2 is a factor of minus 2 and minus 1 is also a factor because minus 1 is also integer. Also, I can say that minus 2 divides 2 because I can write 2 as minus 2 into minus 1. Minus 1 is another factor and minus 2 is also factor of 2. So 2 and minus 2 we can say divide each other, and therefore what is the relation between 2 and minus 2, right? So in general, what is relation between two integers if they divides each other? What is the relation?
Absolute value of
Means their absolute values are same, that means they are plus minus sign only, there is change in sign, right? So that is the only possibility in case of integers. So in case of polynomials, what should be the conclusion? If two polynomials px and qx divide each other, then what happens? There is
Their coefficient are same.
not necessary same. Okay, I will give you example. Coefficients are not necessarily same. Look at this
Q of
polynomial.
x equal to c times p of x.
So they are constant multiples. So if p of x is x plus 1 and q of x
And
is
a does
3x plus 3.
p of x does not equal to 0.
Because we are saying that they are divides each other, means they are non-zero. Both are non-zero, that we are assuming. If you look at px is equal to x plus 1 and qx is equal to 3x plus 3, therefore it is 3 into x plus 1. So now do we understand? Px divides qx and qx divides px. Both conditions are valid in this case. So then there is a non-zero constant. Constant means C, which is constant means it is a member of real numbers. such that Px is equal to this constant times Qx. Right, Px is equal to constant times Qx. And how is it possible, or how to prove this? Right. So since what is given, what is assumption? Assume that Px and Qx non-zero polynomials, and Px divides Qx and Qx divides Px. They divides each other. Right. Since Px divides Qx, so there exists another polynomial h1x such that, right? So by definition of divides, what does it mean? Px divides Qx, that means Px is a factor of Qx. So there is another factor h1x such that Qx is equal to Px times h1x. Right. Also, our assumption is that Qx divides Px, right? Therefore, there exists another factor. Basically, this is in same set of polynomials Rx, right? So there exists another polynomial h2x in the set of polynomials over such that, right, by divisibility, Px has factor Qx and there could be another factor h2x, right? So from this 1 and 2, right? So therefore Qx, but by 1 Qx is Px into h1x into h2x. This is by 1, right? So therefore Px is equal to Px into h1x into h2x. Now simplify this. Px into 1 minus h1x into h2x is equal to 0. These two factors are 0. That means, right, when product of two polynomials is 0, then can I say that one of them must be 0? Is it possible?
Yes.
So like integers, in integers or in real numbers, if a into b is 0, then a is equal to 0 or b is equal to 0. The same thing is true. Remember, the same idea thing is true for polynomials. But by our assumption, what is our assumption? Px is non-zero because we consider non-zero polynomials. Therefore, what is the only choice? 1 minus h1x into h2x must be 0. Right. So h1x into h2x is equal to 1. Right. That means h2x is a multiplicative inverse of h1x. Right. So h2 is multiplicative inverse of h1x. So, but what can you say about multiplicative inverse of polynomials? Which polynomials have multiplicative inverse? Yes.
If they have the same.
Okay. On the other hand, on the contrary, assume that. Okay, leave this thing of multiplicative inverse aside. So, since h1x into h2x is equal to 1, what is the right hand side and what is the left hand side of this equation? So left hand side is a polynomial and right hand side is a polynomial. So RHS is a polynomial of degree. What is the degree of RHS?
0.
0. And LHS is a polynomial of degree. What is the degree of LHS? Degree of H1,
0, 0.
degree of H2, right? So degree of LHS, LHS is the product of two polynomials, and we know that the degree of product is sum of their degrees, and therefore degree of LHS is degree of H1 plus degree of H2, correct? So, but then if two polynomials are equal, their degrees are same. Am I right? If two polynomials are equal, then their degrees are same. Their degrees are same, right? Therefore, what can we say about uh, H1 into H2? H1 into H2 is same as 1, and therefore their degrees are same. So what is the degree of LHS? So degree of LHS is equal to degree of RHS. That means degree of LHS is degree of H1 plus degree of H2 is equal to 0. But degree is non-negative. But degree of any polynomial h1x or degree of h2x is non-negative, and sum of two non-negative numbers is 0, means what? Degree of h1x is 0,
Opposite signs.
but how can it possible to have opposite signs? Then if one is positive, another would be negative, right? Okay, so this is exercise for real numbers, and you should think about it. So if a and b are real numbers, a is greater equal 0, b is greater equal 0, then a plus b is equal to 0 implies a is equal to 0 and b is equal to 0. So you try to prove this. If a and b are two real numbers, and they are non-negative and their sum is 0, then they must be 0. Numbers are 0, no choice. So degree of h1 and degree of h2 is 0, and degree is non-negative. Degree h1 is non-negative, degree h2 is non-negative, their sum is 0, means degrees are 0. Therefore, what is the conclusion? Degree of h1 is 0 and degree of h2 is 0. H1x and h2x are constants, constant polynomials, right? If degree is 0, means it is a constant polynomial, like fx is equal to 3, because it is 3 into x raised to 0, no higher order, higher degree terms, so constant. Therefore, by our previous discussion, what is px? X is qx is h1 times px. So h1 and h2 are constants, and therefore, what is h1x is some constant, say c, or you can say c1, and h2x is also some constant c2, right? Therefore qx is equal to h1x times uh, px, that means it is some c1 times px, or px is by second condition it is h2 times x into qx, but h2 is some constant into qx, right? And therefore two polynomials divides each other. The only possibility is they are constant multiples of each other, right? Yes, is it true?
Sir, can you go up a page or two?
Yes.
A little ahead, so I have to see like the original little
Yes,
one page.
this one.
Yes, sir.
Yes.
Thank you. Yes, sir. Yes, sir.
Is it complete now?
Okay, sir. Thank you.
So, now what is the actually the situation if you compare with integers? So, okay, note if m and n are non-zero integers and m and n are integers non-zero, so m divides n and n divides m, then prove that m is equal to plus minus n, right? That means they are just change in the sign, then only two integers divides each other. And actually m is equal to plus minus 1 times n. And what is plus 1 and what is minus 1? In case of integer, what is the speciality of plus 1 and minus 1 in integers? What is the property of plus 1 and minus 1 in case of integers? Do you understand this? Now you tell me what is the difference between 2 and 1 in case of integers? How will you compare as an integer, which is a crucial difference?
2 is greater than 1.
No, greater is always in real numbers, in rationals, everywhere it is true. But the main difference is 1 has multiplicative inverse. What is the multiplicative inverse of 1 in integers? Yes,
One itself.
One itself.
1. And this multiplicative inverse of 1 is available in integers.
Yes.
And what is
Yes.
multiplicative? What is the multiplicative inverse of minus 1 in integers?
Minus one itself.
Minus 1. Very good. That means this 1 and minus 1 are special in integers because they have multiplicative inverse available in integers itself. But 2 do not have multiplicative inverse in integers, right? So 1 and minus 1 are invertible. Invertible means inverse exists in Z. This is an important property of 1 and minus 1. Other elements do not have multiplicative inverse available in integers. Is it clear what I said? The sentence is clear.
Sir.
Yes, sir.
Right. So that's why if you say that two integers divide each other, then the uh, they are plus minus n, means plus minus are the necessarily those elements which have multiplicative inverse. Now come to the case of polynomials. So if I take fx is equal to 2x plus 3 in Rx. Now my question is, does fx has multiplicative inverse? In Rx? This is my question. Because this polynomial possesses, that means that is Does there exist another polynomial gx in Rx such that fx into gx is equal to multiplicative? Okay, again, multiplicative identity is one that you can prove by other way, but anyway, assume that one is a multiplicative identity in Rx. Then does there exist another polynomial gx such that product is 1? This is a
No.
question. Answer is no, because if we take gx is equal to 1 upon 2x plus 3, then this is not a polynomial. This is not a polynomial, right? Because this expression 1 upon 2x plus 3 do not satisfy properties of polynomial, basic properties of polynomial. So this is not a polynomial, right? So now if I take fx is equal to 3, is it a polynomial in Rx?
Yes, sir.
Right, then f is polynomial. Now I will repeat same question. Does this polynomial possesses multiplicative inverse?
Yes.
Right. Does f
Yes.
possess a multiplicative inverse? And answer is yes. Right. Therefore, what are the elements? Therefore, what are invertible elements in set of polynomials? What are invertible elements?
The constants.
All non-zero constants. So r minus 0, set of all non-zero constant polynomials. So set of all non-zero constant polynomials have multiplicative inverse, and therefore in the previous proof, if two polynomials divide each other, then they are constant multiples of each other because they have multiplicative invertible element, like in case of integers. So that is why this set of polynomials is like set of integers. Only thing is in integer there are only two invertible elements. In polynomial there are many invertible elements. That is the possible difference. Otherwise, the most of the things are similar to the integers in case of polynomials. Okay, is it clear? Okay, so invertible elements in set of polynomials is non-zero constants. That's fine. If px and qx are polynomials in Rx, px and qx are non-zero polynomials in Rx such that px divides qx, then degree. Okay, what can you say about degree? So px divides qx, then can you compare the degrees of p and q? Yes, compare the degrees. Is there any comparison?
Yes.
Yes, less than or equal, right? So same thing is true for integers. If a and b are integers, non-zero integers, a divides b, then a is less equal b. Basically, uh, assume that a and b are positive integers. For negative, you can use absolute value sign. Otherwise, but if a and b are positive integers and a divides b, then a is, must be less equal. Right? This is exactly same as the degree here. Right? Do you compare these two things? What happens in integers and what happens in polynomials? Right? And if you look at fx is equal to x square minus 5x plus 6, and gx is equal to, okay, let us say px and qx, x minus 2, then qx divides px. Sometimes it may happen that they have same degree, still they divide each other, right? For example, if I take same polynomial, just multiply by constant, then polynomials are have same degree but they divides each other, right? So suppose px and qx are polynomials. When I say px and qx are in Rx, that means they are polynomials with real coefficients. Uh, suppose and px and qx are non-zero, right? Now, if px divides qx, then by definition there exists another polynomial Rx. In Rx, right, there is a polynomial in same state such that qx is equal to uh, px times Rx. Okay, then what can you say about this? So now we are saying that in this expression, two sides are same. Now what is degree? So degree of RHS. RHS is a polynomial. What is the degree of RHS? This is the product of two polynomials. Okay, note that degree of QX, degree of PX, degree of Rx are all non-negative quantities. Degrees are the numbers and degrees cannot be negative. Degree is always either 0 or positive. 0 degree polynomial, 1 degree polynomial, 2 degree polynomial. Degrees are non-negative. So the degree of, what is degree of RHS now?
Degree of px plus rx.
Right. So degree of Px plus degree of Rx, because product, degree of product is sum of their degrees. Right. And this is less than, so this amount is always greater equal degree of px, because rx is the degree of rx is a positive amount. If you neglect it, then the sum is smaller. And what is degree of LHS? Degree of qx, and LHS and RHS are equal, therefore their degrees are same. Therefore degree of qx, which is degree of px plus degree of rx, which is greater equal degree of px, because rx is a non-negative amount, and if you neglect, the sum is smaller, right? And so ultimately what we get, degree of px is less than or equal to degree of px, right? Yes,
Yes.
right. So okay, now one more thing you can have about the polynomials. So if px, qx and rx are polynomials over R, so suppose if px divides qx and qx divides rx, then can I say that px divides rx? Is it true? Is it true? It is like integers. If A divides B and B divides C, then can I say that A divides C? Is it true?
Yes, it is true.
Right. And
Yes.
therefore, because we already learned that ki divisibility is a transitive relation, right? If A divides B and B divides C, then A divides C. So transitivity, so divisibility. Same is true for polynomials, and you verify this by the definition of divisibility. So if Px, Qx, and Rx, Qx and Rx are any polynomials such that Px divides Qx and Px also divides Rx, right? Px is a polynomial which divides both of the Qx and Rx. Then for any fx and gx in Rx, now you choose any two polynomials. We have Px divides fx into Qx plus gx into Rx. Now, if you look at three polynomials, Px divides two polynomials, Qx and Rx, and you multiply Qx by any other polynomial, doesn't matter, and Rx by another, and sum this, still Px divide the sum. And this is what about integers? Okay, let me tell you the similar phenomena for integers. So if A, B, C are integers and is non-zero if A divides B and A divides C, then A divides B plus C. First of all, is it true? A divides sum of two numbers, right? If A divides B, A divides C, then A divides sum of B and C, correct?
Yes.
Now further, uh, not only A divides sum, but also A divides AM plus BN for any M and N in integers. So you just take combination of AB with some any other integer, still A, not A, what is this? B, Bm plus Cn. If you take combination of B and C with any other integers, still A divides that combination. So same thing is happening for polynomials. And can you see the proof? Whatever proofs we are doing, and I am writing the equivalent result for integers. So you should write down the proof of that result for integers. Right. So what is our assumption? What is our assumption? Px divides Qx and Px divides Rx. So this is our assumption. Right. Therefore, there exists some polynomial k1x and k2x in Rx by divisibility, right? Px divides Qx, that means Px is a factor of Qx such that Qx is equal to Px times k1x and Px divides Rx. Therefore, Rx is multiple of Px with some another factor k2x. Correct? Fine. So what is our claim? For any fx and gx in Rx, whatever fx and gx you select, no problem. Our claim is Px divides fx into Qx plus gx into Rx. So this sum, Px is a factor of this sum. How will you see this? So now choose any two polynomials fx and gx from Rx. Just close your eyes and select two polynomials, then consider, then what is fx into qx plus gx into rx. So just calculate this expression and see what happens. And can we see that px divides this combination? But by our previous data, what is qx? What is qx? Yes. What is qx? Px into k1x. And what is rx? Px into k2x. Now x is a common. Px is common. So fx into k1x plus gx into k2x. So whatever is common, take it outside. So we started with this combination, we found this. Therefore, px is equal to some k into, so this is equal to px into some k3x. What is k3x? K3x, where k3x is this polynomial, fx into k1 plus gx into k2. And is it in rx? Is k3 in rx? Yes.
Yes, sir.
Right, because it is addition multiplication of polynomials, it is polynomial. So, and what is the conclusion? What is the conclusion? Px is a factor of fx into qx plus gx into rx. Am I right? Correct. So therefore, here it is not restriction that whatever fx and gx you select, every time this is going to happen, provided if px divides q and r, whatever combination you select, px divides this. Right. So is this clear?
Yes, sir.
Okay, now I shared with you a PDF of first chapter. In that I mentioned something about divisibility of integers. Right, so the division algorithm for integers, which we are using since 5th standard. What is the division algorithm? So let a b are integers, a not equal to 0. Basically assume that a and b positive or non-negative. So a is not 0 basically and positive. Same thing is applicable for negative. Anyway, so a and b are integers and absolute value or a is less than b. For assume that a and b are positive, a is less than b, then there exist two integers q and r such that there exist two integers q and r such that b is equal to aq plus r, where r is either 0 or less than a. R is greater equal 0, that means r is either 0 and uh, less than a. Okay, so did you see this division algorithm before? Because you have already used this kind of things. So here q is called as quotient and r as remainder. That means when we divide b by a, then we get some quotient and remainder is always less than a. Is it clear? The statement is clear. Statement of division algorithm, right?
Yes, sir.
Okay. If a and in general this is true, no restriction to put a and b positive. In general also this is true, but it is sufficient to understand for positive. So for example, if you look at a is equal to 5 and b is equal to 3, a is equal to 5 and b is equal to 13, then 13 is equal to 5 into 2 plus 1. So 2 is quotient and no, what is it? 3. So 3 is remainder and 3 is necessarily less than 5, right? But same thing is applicable or true for negative numbers. So if a b is equal to minus 13 and a is equal to 5, right? So remainder is always positive. Remember that. Remainder is always. For example, suppose I want to write down b is equal to a into q plus r, where absolute value of t, r is less than absolute value of t. So r is always positive. This is for general case. So minus 13, b is minus 13. I can write 5 into something plus remainder, and this remainder should be between 0 and 5. So what is here? What is the quotient and what is the remainder? Can I take quotient 4? Can I take quotient 3? Can I take quotient 2? Q is equal to 2. Is it possible?
No.
Q is equal to minus 2. Is it possible? What should be the quotient?
Minus
5 into minus 2 is minus 10. But then minus 13 is equal to minus 10 minus 3. So remainder is minus 3, which is not allowed. Remainder should be positive. So
So
Q is
5
equal
into
to,
minus 3 plus 2.
right, minus 3. So minus 15 and then add 2 will get minus 30. So clearly the remainder is now, so therefore quotient can be negative. So Q is equal to minus 3 and remainder is 2, and remainder satisfy this condition. It is strictly less than absolute value of 5, which is 5. Now same problem I will treat in different way. B is equal to 13 and A is equal to minus 5. So what to do? 13 is equal to minus 5 into some quotient plus remainder, but remainder should be positive. What should be? Yes,
minus 2 plus
minus 2 plus,
Plus 3.
right, very good. So quotient is minus 2 and remainder is 3. And clearly remainder satisfy the condition that it is less greater equal 0 and it is strictly less than absolute value of a, which is 5. Right, so this is a division algorithm for integers. Is it clear?
Sir, is there a formal proof of this theorem?
Yes. So to see the proof, see the book, Elementary Number Theory. By David Burton. So see the number theory, or you may find Acharya sir's book on site, Number Theory, or the book containing topic of integers. right? You may find proof of this, and you should do this proof, or at least learn this proof, how it is proved, right? So probably if you conduct practicals, we'll have a practical on integers. During that session, we'll discuss this kind of things, more about integers. Whatever happening for polynomials is parallel to the integers. Same thing is going to happen for integers, and therefore remember that polynomials are like set of integers. Set of polynomials is like set of integers because similar things are happening, right? So is it clear? The division algorithm statement is clear?
Yes, sir.
Fine. So now I want to state the division algorithm for polynomials. The division algorithm for polynomials. So
Also, sir,
yes,
one more thing, won't the division algorithm hold for like the real numbers and stuff?
see, remember that in case of real numbers, every non-zero element is divisible by any other element because every element is invertible. If you took at 2 and 3 in case of real numbers, 2 divides 3, no problem, because 3 is equal to 2 times 3 by 2, and both factors are available in real numbers. Do you understand this?
Oh, so there is no point of
Right.
division.
There is nothing non-trivial. The things are trivial in case of the set where all non-zero element divides each other, right? So if elements are invertible, then the that is called as a field. In algebra, there is a concept called as a field. All elements have multiplicative inverse except 0. In that case, there is no point in studying divisibility, right? So okay,
Actually, sir,
yes,
um, while studying for like the maths and calculus, I actually came across the term field properties. Could you
yes.
elaborate a little on this more? I wasn't able to understand why it was called all that.
Yeah, during our practical sessions, once we complete our syllabus, we'll discuss the practical sessions, practical problems. During that, we'll discuss these ideas. Because field means what? Whatever properties you learn for real numbers, right? Algebraic properties or field actions, anything satisfying those properties is called as a field. And what are the properties? Key, addition, multiplication. Every non-zero element has multiplicative inverse. That is a key point. And A into B is same as B into A. So whatever properties of real numbers are there, anything satisfying those properties is called as a field. And here we are studying R is a field, and we are studying polynomials over field, and therefore polynomials over field like integers. And this is what a higher algebra. If you learn higher mathematics and abstract algebra, then you can understand all these things. What are integers? We are using integers conveniently. What is the basic idea behind integers? And for that, you need to learn higher algebra, right? Yes.
Okay, sir.
So if you are interested, you can read a book of abstract algebra, J.B. Fraley. J.B. And don't read right now. After your exams are over, this first semester, then you can read this book. J.B. Fraley, you will get soft copy of it. Or there are many other books. Okay, fine. So, division algorithm for polynomials. So let fx gx are polynomials in Rx such that uh, gx is non-zero, Right, so take two polynomials and gx is non-zero, like integers, like take a integer c and b is non-zero. Right, so whatever we are studying in parallel lines, and therefore not difficult to understand. So fx and gx are polynomials and gx is non-zero, then there exist unique polynomials. There exist unique polynomials qx and rx, unique. Whatever quotient and remainder we find in the division algorithm for integers, the quotient and remainder are unique. Unique in the sense the remainder lies in between 0 and absolute value of a. With respect to that condition, it is unique. Somebody may find some different remainder, but that remainder is larger remainder or negative remainder. That is not allowed. So such quotients and remainder are unique. Right. So here quotient is a polynomial and remainder is also polynomial, such that fx is equal to gx into qx plus rx. Right. So fx is equal to gx into qx plus rx. And what is the restriction on rx? Like in integers, what was the restriction on r? R is greater equal 0, or r is less than a. So what is the restriction here? Where rx is 0, that means remainder is 0, because if you are looking at two integers, either one divides another, that means remainder is 0, or remainder is non-zero, that means rx is 0, or degree of rx is less than degree of gx. Right, so here degree of, we are dividing by gx, so degree of rx is, degree of remainder is always less than degree of this gx. The statement is clear. Any doubt? Yes. So let fx is equal to 3x raised to 5 minus x cube plus 3x minus 5, and gx is equals to x square plus 7. Then find quotient and remainder. Find uh, qx and rx such that fx is equal to gx into qx plus rx. So how will you find this? By division, synthetic division. You know synthetic division or long division, right? You know the division of two polynomials. 3x raised to 5 minus x cube plus 3x minus 5, and here x square plus 7. How do we divide two polynomials? First, look at the highest degree term, 3x raised to 5, and divide by here highest degree term, x square. What we get? 3x cube. Put 3x cube here, then multiply by then 3x cube into x square plus 7. Multiply this. What we get? So multiply this to this. 3x raised to 5 plus 21x cube. Correct? 3x raised to 5 plus 21. Is it correct? X cube. change the sign or subtract. So this will get cancelled 0. So minus x cube minus 21x. So minus 22x cube plus 3x minus 5. So bring this, right? Do the same procedure in this step. So what is now minus 22x cube divided by x square? What remains? Minus 22x minus 22x. Then minus 22x multiplied with again x square plus 7. What you get? Minus 22x cube minus 22 into 7x, whatever is this number, right? So what you get? Minus 22x cube minus 22 into 7x
Minus 154.
So okay, now change the sign. Minus 154 and plus 3, what it will be? So now plus 154 plus 3, so 157x minus 5. But now here degree of this final expression is 1 and degree of the polynomial by which we are dividing is x square is 2. Now we should stop here because further division is not possible, right? If we divide 157x by x square, then we'll get 1 by x term, which is not polynomial. So we should stop here. This is quotient qx, this is remainder rx, right? This is gx and this is fx, and write down the expression. And what is the degree of Rx now? 1, which is less than degree of Gx, which is 2. Correct? Do the similar calculations for this. Fx is equal to x cube plus x plus 3 and Gx is equal to x plus 3. And find quotient and remainder. Find qx and rx such that fx is equal to gx into qx plus, right? So you work out this. Okay, we'll stop here now. Now we'll have one more lecture at 3 o'clock today, right? Do you remember? Today we'll have one more lecture.
Okay, sir.
Right. So we'll see